Today, we're going to learn how to interpret numerical expressions. Let's begin by learning a new term called the cumulative property of multiplication. This rule states that if you have a multiplication problem like 4 times 5, it does not matter which is the first or second factor. You will still get the same answer. You can say 4 times 5 is 20, or you could say 5 times 4 is 20. The order of the first and second factor does not change the product, and the product is the answer to a multiplication problem. We learned yesterday that there is a certain order to solve equations with more than one expression. An expression are a series of numbers and symbols such as addition, subtraction, multiplication, and division without an equal sign. So gotta remember we always work from left to right. And the please excuse my dear Aunt Sally, where you work with your parentheses, then your exponents, multiply or divide, and then add and subtract. Can you think of all the different words that tell you that you need to add something? And what about all the words that tell you to subtract? Can you think of them? What words mean you should multiply? And what words tell you to divide? Think about that. Let's take a look at this anchor chart. What this anchor chart tells us is that when they say are not, they mean, if you see that, you're going to be doing some subtraction. When they say divisor, the problem must mean division. In your math notebook, on the next clean page, you are going to create the expression anchor chart. Make sure you take up your whole notebook page, okay? You can make a 4 square, and then right in the middle put when they say ... they mean ... Label this one addition, subtraction, multiplication, and division. And then in each of the boxes, you're going to write what they say in each one, so that when you see these words, you know, oh, I'm looking at a word problem and it says less than. Well, less than, I must be going to divide. Okay. Also notice the relationship between addition and multiplication. For addition and multiplication, our numbers are going to increase. For subtraction and division, our numbers are going to decrease, meaning our answer is going to be smaller. So go ahead and take a couple minutes and create the expression anchor chart in your math notebook. Here is an example of an expression. When an expression is worked out, it is called an evaluation of the expression. So when you see us solving 5 times 4 plus 3, and we have the number 7 here, and then we have 5 times 7, and then down here we have 35. That would be an evaluation of the expression. Where, when we have the expression and we have it equaling 35, now it is called an equation. So an expression, you don't have an equal sign. An equation, you do put the equal sign. So the expression 5 times 4 plus 3 is 5 times larger than the expression 4 plus 3. So today we're going to be evaluating the relationship between expressions and writing the expressions out in words. So if you read this, 5 times larger than 4 plus 3, you would need to solve for the equation. You would write 5 times, parentheses, because you need to do this part first, 4 plus 3. You can also write the exact same expression, 5, parentheses, 4 plus 3. You don't necessarily need to put the multiplication symbol. You can write it either way. It means the exact same thing. So if I need to solve for the equation, I need to have an equal sign. So I would have 5 times 4 plus 3. I would have 5 times 7 equals, 5 times 7 equals 35. So I took it from word form and I wrote an expression. Go ahead and translate these words into a math expression. So I have 25 minus the product of 3 times 4, which equals 13. 5 multiplied by the difference of 16 and 9. By the difference tells me I'm going to subtract. Go ahead and translate this math into words. "84 minus 16. 18 divided in half, or you could also write 18 divided by 2. Notice that you need to write all the numbers into words. So I shouldn't see the number 84 and then the word minus and the number 16. Okay, you need, when it says translate math to words, everything needs to be a word. Go ahead and translate this math to words and solve. Or, I'm sorry, don't solve. Just translate it. So you should have 42 minus the product of 5 times 6. You could also say 42 minus the product of 5 and 6. Because as soon as you say product, that still means times. For the last one, 95 divided by the difference between 12 and 7. Now you're going to need to solve these, because do these phrases mean the same thing? So go ahead and solve these two problems. If I have 50 minus 18 plus 7, it would look like this. 50 minus 18 plus 7. Well, working left to right, 50 minus 18 is 25. Plus 7 is 32. Whereas the sum of 18 and 7 subtracted from 50, so I know that this is going to be subtracted from this. So I'm going to put this number first. 50 minus, and I need to find the sum, so 18 plus 7 is 25, subtract this number by 50, and it equals 25. And looking at this, I goofed on this one. This should read 50 minus 18 plus 7. 50 minus 18 is 32. So it should be 32 plus 7 equals 39. So this one is actually incorrect. It should be 39. What does the expression mean? If I have 100 minus 25 divided by 2, my expression would be 75 divided by 2, or divided in half, would be 37 and a half. Whereas this expression means I need to solve for this. 19 plus 31 is 50. 200 minus 50 is 150. What is the difference between these two expressions? This one says 32 divided by 4 equals 8. Where this one says 32 divided in half, or divided by 2, is 16. So even though it starts off the same way, when we divide it by this number, we get a different answer. Go ahead and translate this word problem into an expression and solve. For this one, there's two different things that you need to solve before you can subtract. So David earned $10 an hour for 8 hours. Well, I need to know how much he made during this time. And $9 for 6 hours. Then he spent $75 on new cleats. So I need to really find out how much he earned first before he spent his money. So I'm going to use brackets and parentheses. The brackets tell me I'm going to do what's inside of here first. So in brackets I have 10 times 8 plus the product of 9 times 6. So I need to add these two numbers first before I can subtract. So 80 plus 54 is 134. 134 minus 75 is 59. So David has $59 left. Go ahead and solve for this problem. When I read this, Athea had $40 and spent $8. Then she decided to save half of what she had left. Well, she can't save half until she figures out what she has left. So we have to do the 40 minus 8 first and get 32. She decided to save half. Well, saving half would be dividing by 2. So 32 divided by 2 is 16. She saved $16.